This is going to be the conclusion of the hydraulic lab, and we're going to be plugging in the information from the other sheet to calculate the mechanical advantage in each of those scenarios. We're going to go with questions numbers 1, 2, and 3, and that will be all that we'll be doing. The rest of these correspond to different portions of the lab which we didn't do. So we're going to review the results from the experiment data table 1. Was it easier to move a 20 milliliter plunger by pressing the 1 milliliter or move the 1 milliliter by pressing the 20 milliliter plunger? So again, going back to lecture, which is it easier to move, the smaller one or the larger one? And it's easier to move the smaller one. So it's easier to move the smaller of the pistons. Now this says, explain using Pascal's law. Well, if you remember, pressure 1 is equal to pressure 2, meaning the pressure on one side is going to be equal to the same pressure on the other side. And the force over area is equal to the pressure, and this is the formula that we get. Pressure is equal to force over area, so the force 1 over area 1 equals force 2 over area 2. Okay, so we're going to be taking a look at the F2 is what we did in lecture, but if we're trying to do the force of 1 and we're trying to isolate this, if we multiply both sides by A1, multiply both sides by A1, that's going to then cancel. What is my force going to be equal to? Well, my force is going to be equal to whatever force is going to be exerted on the larger. But now take a look at this time. A1 over A2. A1 is the smaller of the two, and the A2 is the larger. So if we rearrange Pascal's law in this way, what we see is that the force on the input is going to be the smaller because the ratio of the areas is actually going to be smaller. So let's plug in some of our data. We're going to try to determine the ideal mechanical advantage. If you remember, this is something that we looked at last semester. And the formula for the ideal mechanical advantage is going to be equal to the distance of the effort over the distance of the resistance. So we want to have large mechanical advantages, or even large ideal mechanical advantages. So the more that it moves, the more a mechanical advantage that we have. So to rearrange this formula, we're going to say that the distance of the effort is the distance of the input over the distance of the output. So if we take a look at this, we're going to have 5 equations. We're going to have to use the space. So we're going to go over here for our first one. So how much did the 1 milliliter input move with the 20? This moved 5 centimeters. And the output moved 0.3. Going over to the second one, we're going to do the second one over here. This over here. The 3 milliliter moved, for the input it moved 5, and then the output moved 1. For this next one with the 3 and the 3, they each moved 4.5. Of course, that would produce a mechanical advantage of 1, which does not indicate that it's a good machine, anything that's larger than 1. So the 20 and the 3, this is actually just, this is going to be this reversed. It's going to be the 1 over 5. And if you input all your force on the 20, it's going to be 1 over 20. So I'm going to get my calculator out real quick. 5 divided by 0.3, this would give us a ideal mechanical advantage of 17. 5 divided by 1 would be 5. This would be mechanical advantage of 1, this would be 0.2, and this would be 0.05. So you can see that the mechanical advantage gets less and less and less when you have the very pushing on the larger piston and having the very small piston on the other side. When you are having the small piston pushing all your force there, you have a very large mechanical advantage. So compare the mechanical advantages of calculations from question 2. How hard or easy is it to move the respective input plunger? So, of course, again, this is going back to the initial one. It's easier to move the smaller one. So the smallest one, or the smaller, or even the smallest piston has the highest ideal mechanical advantage, meaning that it's going to be the easiest to use. And of course, is it better to have a large mechanical advantage? It's the highest. The higher, the better. The more efficient that you're, not more efficient, but the easier it is for you to use your machine. That's the third part, and that's the conclusion of this lab.